Hello viewers, in today's class we are going to discuss one important problem from derivatives, right? And here we have one problem. We have to differentiate this function with respect to x, right? So here we have the function that is the cosec inverse 1 plus x square over 2x plus cos inverse square root of 1 plus x divided by 2, right? So we have to find the derivative of this function with respect to x, and here we'll make use of some trigonometric substitution to simplify this expression, and then we'll find out the derivative, right? So let us call this function as y, right? So we have this function, and let us first simplify this function before uh, differentiating this function with respect to x. So now here this function y, it comprises of two functions, right? The first one is cosec inverse function and the second one is cos inverse, right? So let us first change this cosec inverse function to sine inverse function, right? So here we'll use a result from inverse trigonometric functions, that is cosec inverse say theta is equal to sine inverse 1 over theta, right? So here theta is 1 plus x square over 2x, right? So let us write y is equal to sine inverse. So here we are converting cosec inverse to sine inverse by using this result, right? So sine inverse, we have sine inverse, and here we'll write the reciprocal of this term, that is 1 plus x square over 2x, right? Because here we have theta and here we have 1 over theta. So theta is 1 plus x square over 2x, right? So here we have the reciprocal of this term. So we have 2x over 1 plus x square. And here we have cos inverse square root of 1 plus x over 2. So we'll keep this term as such, right? Okay, so now we have two functions, the sum of two functions, sine inverse and cos inverse, right? Now here we'll make use of some trigonometric substitution to simplify this function, right? So what we will do, we'll concentrate on this part and this part, right? So in this part what we will do, we'll take x is equal to say tan alpha, right? So here we take x is equal to tan alpha, and in this part we'll take x is equal to say cos of 2 beta, right? So we are making this substitution to simplify this function, right? So now y can be written as sine inverse, and here we have 2 tan alpha divided by 1 plus tan square alpha, and here we have cos inverse, and here we have 1 plus cos 2 beta divided by 2, right? So now we have some well-known results from trigonometry, right? So the first one is C. We know that sine 2 alpha is given by 2 tan alpha divided by 1 plus tan square alpha, right? So this is a direct result from trigonometry. So sine 2 alpha is 2 sine alpha cos alpha, right? So this result can be expressed in terms of tan alpha alone, right? So sine 2 alpha can be written as 2 tan alpha over 1 plus tan square alpha. So here we can now write sine inverse sine 2 alpha, right? Okay, now let us take this term. So here we have cos inverse, and see again from trigonometry we know that cos of 2 beta is given by 2 cos square beta minus 1, right? So this is the double angle formula for cosine function, right? So if we take 1 minus 1 to this side, we have 1 plus cos 2 beta is equal to 2 cos square beta, and dividing both sides by 2, we have 1 plus cos 2 beta divided by 2 is equal to cos square beta, right? So now here we have square root of cos square beta, right? Okay, so now we can write sine inverse. Here we have sine 2 alpha, and here we have cos inverse of cos beta, right? So we can take cos beta from this square root sine, right? So now we have arrived at this result, right? Now from inverse trigonometric functions, we know that sine inverse of sine x is equal to x, right? So here we can assume it like this, that is sine and sine inverse get cancelled and we are left with x, right? And similarly cos inverse of cos x is equal to x, right? So now here we have y is equal to simply 2 alpha, and here we have simply beta, right? So sine and sine inverse get cancelled, 2 alpha, and here cos and cos inverse, so we have beta, right? So now we have y is equal to 2 alpha plus beta, right? So now see, we have assumed that x is equal to tan alpha, right? So we can now write alpha is equal to tan inverse of x, right? So here we can now write 2 tan inverse of x, because alpha is now tan inverse x, right? So we are again converting this result to in terms of x, right? And here we have beta. So from this result we have 2 beta is equal to cos inverse of x, and beta is equal to half cos inverse of x, right? So here we can write half of cos inverse of x, right? So now we have y is equal to 2 tan inverse x plus half cos inverse x, right? Now we can differentiate both sides with respect to x. So dy over dx is equal to the derivative of tan inverse x, and then here we have half and derivative of cos inverse x, right? So we know the well-known results for the derivative of tan inverse x, because these are the standard results in differentiation. So derivative of tan inverse x is 1 over 1 plus x square, and here we have half, and derivative of cos inverse x is negative of uh, minus 1 divided by square root of 1 minus x square. So we have 2 over 1 plus x square, and here we have minus 1 over 2, and here we have square root of 1 minus x square, right? So this is the required derivative of this function with respect to x, right? Now let us consider one more problem, right? So here we have to differentiate this function with respect to x, right? So here we have sine inverse, and we have x times square root of 1 minus x minus square root of x times square root of 1 minus x square, right? So let us call this function as y. So here also we have to find dy over dx, right? So viewers, here also will make use of the trigonometric substitution, and will utilize some standard results from trigonometry, right? So here we have some interesting trigonometric substitution. So here we'll take x is equal to say sine of alpha, right? So here we'll assume x is equal to sine alpha, and square root of x as sine of beta, right? So here we'll make the substitution. X is equal to sine alpha and square root of x as sine beta, right? So now this function, it becomes y is equal to sine inverse, and see, for this x we can now write sine alpha, right? And here we have square root of 1 minus x, right? So here we are not going to substitute sine alpha. Why? Because see, we have to neutralize this square root sign, right? So for this, what we will do, we'll make the value of x from this expression, right? So here we have square root of x as sine beta. So if we take the square of both sides, we'll get x is equal to sine square beta, right? So for this x, we'll take sine square beta, right? So we have 1 minus sine square of beta, right? So here we have to be very careful that for this x we can take sine alpha, but for the x which is inside the square root sign, we'll take x is equal to sine square beta, right? Okay, so now here we have square root of x, right? And for square root of x we can now write sine of beta. So here we have sine beta, and now we have square root of 1 minus x square. So for this x, we'll make use of this substitution, that is 1 minus sine square alpha, because x is sine alpha, right? So here in this problem, we are taking two types of substitutions for x, right? So this is an interesting thing in this problem. So for this x and for this x, we are taking sine alpha, and for this x and for this x, we are taking sine beta, right? So here we have y is equal to sine inverse, and here we have sine alpha, and here we have square root of 1 minus sine square beta is cos square beta minus sine beta, and here we have 1 minus sine square alpha, so this is square root of cos square alpha, right? So now we can write y is equal to sine inverse. Here we have sine alpha, and square root of cos square beta is simply cos beta minus sine beta, and here we have square root of cos square alpha as cos alpha, right? And here we can see that this expression is a well-known result from trigonometry, right? So we know that sine a minus b is equal to sine a cos b minus cos a sine b, right? So here for a we have alpha, for b we have beta, right? So y can be written as sine inverse, and here we have sine of alpha minus beta, right? And from trigonometry we know that sine inverse of, say, sine x is given by x, right? So this sine and sine inverse may be treated as cancelled, so we have x, right? Okay, so here we have sine and sine inverse get cancelled, so y is equal to alpha minus beta, right? So y is alpha minus beta. So now we have y is equal to alpha minus beta, and from this expression x is equal to sine alpha, alpha is sine inverse of x, right? And from this expression we have beta is equal to sine inverse of root x, right? So now y is sine inverse x minus sine inverse of square root of x. So the simplified form of the given function, by making this substitution, we have y is equal to sine inverse x minus sine inverse square root of x, right? So now we can differentiate both sides with respect to x. So dy over dx is equal to d by dx of sine inverse x, and here we have d by dx of sine inverse of square root of x, right? And from calculus, we know that the standard result for the derivative of sine inverse theta is 1 over square root of 1 minus theta square, right? So here we have 1 over square root of 1 minus x square, and here we have sine inverse square root of x, right? So for x we have square root of x. So here we have to make use of chain rule. So first we have 1 over square root of 1 minus square root of x square, and then by chain rule we have the derivative of square root of x, right? So now dy over dx can be written as 1 over square root of 1 minus x square, and here we have 1 over square root of 1 minus x. Square of square root of x is x, so we have 1 minus x, and the derivative of square root of x is 1 over 2 times square root of x, right? So viewers, this is the required derivative of this function with respect to x.